Okay, so far what we did, we consider a cylindrical pressure vessel, right? Subject to uniform pressure. And we figure out what will be the stress in the cylinder. This is the formula. Also, you can this one. This is tangential stress or hoop stress, sometimes also called circumferential stress. Both are same meaning. And other stress is longitudinal stress. This one, sigma L equal to PR by 2T. So what we found that sigma T is most critical. It is double of sigma L. So if your pressure vessel survive by sigma T, obviously it will survive by sigma L. For example, we found sigma T 36 KSI pressure stress, then sigma L will be 18, half of sigma T. Okay, now if you pressurize a pressure vessel, then what will be happen? Inside it volume will increase. Also, a length will increase. For example, you buy a birthday balloon and you pressurize by your mouth. Then what happen? Is length also increase? Sometimes you see along this direction, diameter also increase. So diameter increase due to the pressure working along this side. That means it creates sigma T. And length increase due to the working of sigma L, and sigma L is found. That's why when you put air in a balloon, it's extremely elastic, right? Also not metal, synthetic, but it has certain elasticity. So when you put air, the length increase, diameter increase. But if in compared to metal pressure vessel, we are not worried about that mass increasing of length. We are worried about increasing of diameter or radius, because say you are transmitting pipeline from Kumilla to Dhaka or Sylhet to Kumilla, then the length of the pipeline will not increase that much compared to the total length, but diameter might be increased little bit. So when you pressurize a cylinder, we need to figure out how much radius will increase. So if you have option, you can measure the diameter of the cylinder before pressurize, after pressurize. So you can figure out, right? If you just wrap a tape around the cylinder, you get the 2 pi r. That will be initial length, peripheral length, if I say pi. And after you pressurize, your diameter will increase little bit, right? So r plus delta r. This much diameter increase. So total peripheral length will be pf. Now you subtract these two. You can figure out how much radius increase by measurement. So say radius increase by delta r, right? Now, this one you measure by measuring with the tape. But as engineer, you cannot measure every time with the tape. We need to have a formula that how much stress is increase. Okay. So right here, you see, you can figure out the peripheral strain. What is the strain? Strain equal to delta L divided by L. What is delta L? Change of length. So epsilon T. Why I put T? Along tangential direction. Peripheral length increase. So this equal to how much length increase? You can figure out PF minus PI divided by initial length. So your initial length was 2 pi r. And you subtract this one and this one, you will get PF minus PI. So easy put it over here, right? Now you got sigma t. Now we know the Hooke's law. What is Hooke's law? Sigma is proportional to epsilon into E. So this sigma, I can say sigma T equal to strain along tangential direction into E. So from here, you'll get some relationship with delta R. That one you put over here, this one. Then we can figure out the change of radius after you pressurize the cylinder. For example, if you use car, you take, for example, you tank full with of gas amount 500 taka. Normally, we don't look that how many meter cube of gas inside the cylinder, right? So when you take the full tank, then diameter of the cylinder is increased, but we cannot realize that much in our eye. Then within 1 week, you burn all the gases by driving your car. Then what happened? Pressure inside decrease. So cylinder will try to come back in previous shape. So over the month, one time cylinder expand, one time shrink. So might be 4 times at least. Then over the year, over the 5 year, one time expand, one time shrink. So that means it work like a spring, like this one. Right now, I cannot break it, right? But if I do several times like that, it will break. That is called fatigue failure. So in the car, there might be crack developed inside the cylinder because one time expanding, other time it is, shrinking. How can check it? You can put a camera inside. So you put a camera inside, all gas will be out, right? Then there will be no gas. No gas, metal will come back previous shape. Even there is a crack, but you cannot see by your uh, camera. But when you pressurize with the gas, then your crack will say, for example, this is the wall of your cylinder. So say there is a micro crack like that. When you pressurize, this gap will gradually increase. But there is no gas, you will see there is no gap, you cannot see. So very difficult. to realize. So that's why there is a rule that every 5 years you have to test your cylinder. And how they test it? They pressurize the cylinder with the water or air, then hold it. So for say 2 minutes or 1 minute. If cylinder is weak, then it will burst and pressure will suddenly decrease. That's why they test it. Like you take in Navana or Southern, whatever their service center, they do the similar way. They clean the cylinder, then they pressurize. When they pressurize, volume increase. They figure out the how much liter of water is going inside. Say cylinder volume 5 liter, they're putting water 8 liter. That means it is pressurized, right? Then you keep it and look at the meter. Keep it that about 1 minute or 60 seconds or might be 1.5 minutes. I'm not sure what is the exact time they keep. So if it remain, say if there is a crack, then what will happen? Gradually crack will increase, cylinder volume will decrease, right? Then you'll see your pressure is dropping. That means is something wrong in the cylinder. But it is remain constant, that means there is no crack. That's why they give certified, you know. Now, what was our main point? To figure out how much radius is increasing in the pressure vessel. That will figure out. So here is the main formula. I just give you preliminary idea. Okay. So right now, this is the tangential stress in the cylindrical pressure vessel. Say in radius is R. So what will be initial peripheral length? Pi equal to 2 pi R. And after you pressurize, this mass amount delta R radius is increased. So what will be the final peripheral length? This one, right? 2 pi into R. Now R is increased. So what is our target? Our target to figure out this value, this delta R. Okay. Now we'll figure out change of length. Peripheral length delta P equal to PF minus PI. So this is the PF and this is the PI. So this is the change of length. If you, this is peripheral length, not the radius, right? So I like to figure out peripheral strain. Strain means change of peripheral length divided by original length. So ET equal to PI, initial peripheral length divided by change of length. So Pi equal to 2Pi and delta P equal to 2 pi delta R. Now you see if you simplify, this two term is out. So you are getting delta R by R. This is epsilon T, that means strain. Now you apply the Hooke's law, I can say sigma T equal to epsilon T into E. Now epsilon T equal to sigma T by E. And what is the sigma T? Right over here. PR by T into 1 by E. On left side, you substitute epsilon T with this value, sigma R by R. So sigma R by R equal to this one. Then you figure out delta R. equal to PR square into ET. So you see, you can easily figure out that how much radius is increase or decrease in the pressure vessel. Other thing you remember, pressure vessel, it don't mean that it will have pressure only inside, say only inside. That is normal thing, and it sometimes is true, like boiler. Outside atmospheric pressure, inside boiler pressure. We use the pressure vessel in our car gas cylinder, inside high pressure, and outside it has little bit pressure that is equal to atmospheric pressure, right? This is ideal situation, but in some situation pressure might be outside high, inside might be low. So in this case, right, I show in the figure, in this case, the diameter or radius of the pressure vessel will increase. But if we say a submarine in going under water, say this is the water level going 2 mile deep. Then what is the inside pressure? Inside they live there some intelligence people, military people, or other secret people, right? They are spy people. So they need to keep pressure inside, like close to the atmospheric pressure. But then what will be the outside pressure? Depends on how much the depth. P equal to, we know that from fluid mechanics, pressure equal to rho g h. So if the height is too deep, big, so outside pressure will be high. So in that case, what will be happen? The radius of the submarine will decrease. Okay. So radius can be decrease, can be increase, but we can figure out by using this formula. Excuse me. Now, you, you need to know how pressure vessel is made. Normally, what they do, say you have a sheet metal, either aluminum or say steel. Say it has a certain thickness of the sheet, right? Then you roll it. You roll it, then you do the welding around it. Then like this is a paper, this is a sheet. Now this sheet, you roll it, do the welding right over here in the cap and both cap, then you have the pressure vessel, right? So normally we use the pressure vessel in our home or car, even boiler. The thickness is not that much because inside pressure is not too high. But if inside pressure is too high, then you need to increase the thickness of the wall. And sometime you see, I have seen that thickness become about 2 inches. And I used to work on a project They make a cylindrical pressure vessel. Say, this is upper half, okay? That's I am showing you. This is upper half. So bottom half will be like that. Say this is bottom half, okay? And they put together this bottom half, and then they put a joint over here with a plate. Then, and obviously there is no gap between right over here, okay? Then they make a joint and make the pressure vessel. That one actually for a space shuttle for a private company. But normally, if you work those kind of project, you will not know that these parts is belong to which company. Normally, they give a parts number with numerical number, or they give you the drawing, and you cannot find that this drawing belong to which company. They will not release. This is the part of the contract. Okay. So you see, this thickness was more than 2 inches. So I see that we bring the parts, and also we bring it in our company to make this joint, because if we can make a hole in the bottom part and also upper part, this surface, and you have to put a plate to join, and you need to make sure that that hole are straight. Okay, there is nothing problem, and it is difficult because it's a curved surface. Then you need to make a hole. Okay, and you have to make a special jig and fixer to hold that parts in the machine table. Okay, so after bring the parts, after 1.5 months, we check the radius. Then we see radius is increased. What is the reason? Because how they make this sheet. What they do, they have a sheet, they put a steel roller, extreme pressure, little bit they put pressure, and they roll it like that. Then gradually the sheet become round, become like that. So it depends that what is the size, what is the diameter, what is the thickness of those wall or plate. So in US, only about 15 company, specialized company, they only roll the aluminum plate or steel plate. So our company, they buy the plate, they send it to other company. They roll it, then ship it to us for a rest amount of manufacturing process. So what I like to say, this is expensive, also difficult to roll a high thickness aluminum or steel plate. Like this one, we overcome it. What we did, we send it to the heat treatment plant. So, radius is increased a little bit. Then they, again, they put a pressure from the outside to reduce the radius. They heat up the parts a little bit, then cool down at room temperature slowly. Then they say there is no change in diameter if you keep the parts for next 20 days. Okay, that's why we overcome. But what is the problem over here? If thickness is too high, then it is very difficult to manufacture and also uh, costly. So if you have very thickness of your pressure vessel, instead of one plate or one cylinder, you can use composite cylinder. Composite cylinder mean a smaller pipe you just put in of a inside of bigger one. So scenario you are coming like that. This is a okay. This circle I cannot move it. Say this is one plate, one or pipe you can see, and inside is other one. So how do you see? Say this total thickness, for example, is 3 inches. So if you like to use only one tube or one pipe or pressure vessel, then you need to 3 inch thick steel plate. Then they'll roll it, bend it, then they do the joint. Now you have option. You can take this one 2 inch thickness, this one 1 inch thickness. Then they push together. That means one bigger pipe, it has a inside another pipe, right? Or you can make it like 1.5 inch and this one 1.5 inch. That is called composite or compound pressure vessel. Okay. If you use two different material for outer and inner cylinder, that will be kind of composite. But if you use same material, that you can say annular cylinder, or you can say combined cylinder, right? So in that case, actually what happened? This one say inner cylinder. So this inner cylinder should have a outer diameter, right? 1 second. Say this is my inner cylinder. So obviously, let me pick up the line. So obviously it has inner radius. So this one is in inner pipe or cylinder. Similarly, you have one more outer one. So this one, and it will have radius inner one, right? So this is outer pressure vessel or outer layer, you can say. This is outer one. So it will have two radius, outer radius, inner radius, right? Inner radius. Similarly, this one will have outer radius. Also, it will have inner radius. If blue radius is both same, say this one blue, this one say I'm just saying 30 centimeter, and this bigger say cylinder, it has radius 30 centimeter. Then this one, the smaller one, can go easily in the inside of bigger pipe, right? Then you can pressurize. But what is the problem over here? It both has a common diameter, right? After you put together, then what will be happen? That this will be diameter of outer cylinder. It will be his inner diameter, and this is the inner one. So you see, this is outer, this inner diameter of smaller tube or cylinder, then from here to here, this is common radius, right? So both is 30 centimeter. That means for outer cylinder, Ri 30 centimeter. For inner cylinder, outer radius are not equal to 30 centimeter. So both you can easily put together. But what will be happen at the surface? They will slide because both has the same diameter, and even other thing that even you say make it 30, they cannot make it 30 centimeter. They might able to make it like 29.98. You take measure other place, your radius might come 30.05, right? Nothing you can make with accurate dimension. That means there is some tolerance. So one place it will slide, other place it might be hold tightly. So if it is slide after pressurize, then you burn all your gases, or inside pressure is reduced, then again it will slide. So life of the cylinder will reduce. So for that reason, we can do two things. Number one things, we can make the inner cylinder outer diameter little bit bigger. So this is outer, right? Outer diameter of the cylinder. You make the little bit smaller. Say I'm saying this his inner diameter you make 29.9875 centimeter. Then what will happen? This is 30 centimeter, and this is 29.9875 centimeter. So you cannot put it easily. You can bring the smaller one, mouth of the bigger one, you can hammer it little bit, then it might go inside. But if you do hammering, there is a possibility to develop a crack inside the wall. Crack might be developed like this surface, inner surface of outer cylinder, or outer surface of inner cylinder. So this option is not acceptable. Other option you have, you can heat up this the outer cylinder, then metal will expand. That means this diameter will go little bit bigger. After heat up, you might have diameter 30.01 centimeter. Then you can put easily inside and keep it at the room temperature and cool down for say 2 days or 1 days, or might be 8 hours. Depends on size of the parts and material, what is the environment like. Then what will be happen after cool down? Diameter for inner outer cylinder, he will try to back this 29.875 position, right? And inner one, what will happen? When he try to shrink, then what will say this guy? Hey guy, don't push me. I like to stay with my size. And the outer cylinder, he will say, hey guy, don't push me. my radius is 29.9875. I like to gain my shape, right? Then they will compromise, and instead of this one, they might have a common radius, right? 29.980 centimeter. So what is happening? It's 29. That means this common radius. That means the outer cylinder radius little bit decrease, right? And this one also decrease. They have a some common radius. Okay. What happened? Say in the common radius. So I with this one I holding my hand. So I am pressing my hand, applying pressure from the top, all the side, right? But if I have a muscle man, normally you call six-pack man, then what will happen? I'll feel pressure right over here. That means the inner cylinder will experience a pressure from outside, from the outer cylinder. And the outer cylinder, he will experience pressure right over here, this one. And this pressure is coming from what? Coming due to interference fit. Because diameter we need 30, but right over here you keep little bit less. So what is the interference? 30 minus this value. If this interference is big, then what will be happen? You need to cool down more, right? But if you cool down more, then this contact pressure, there will be contact pressure right over here and right over here. For example, you hold your friend hand extreme tightly. What will say? He might shout, "Hey guy, I'm getting hurt. Don't press me," right? So that means that he's applying pressure at the surface. That is called contact pressure. But if your friend muscle is stronger than you, then you might feel pressure around your hand. Okay, so it depends on how tightly he is holding and how the difference in two muscle. That means the depends on the interference. This contact pressure will develop at the contact surface, right at the this common radius. And due to this contact pressure, sometime you make the assembly, then there might develop crack over here, or it might be burst, fail. So you need to make sure that this contact pressure is not that much. So as a engineer, if you like to put some interference, then you need to figure out what is the amount of interference and how much pressure will develop. And due to this pressure, what will happen? This inner cylinder try to be squeezed and outer cylinder try to be expand. And then there will be sigma T, and also over here will be sigma T, but this will be compressive. So you need to make sure that sigma T is not that much. Okay. Now, if you got the value of P, you can easily figure out the sigma T. But how will figure out the contact pressure? So we need a formula, right? So we know one formula, that due to the pressure, radius increase or decrease, we can figure out by this value. So right over here is showing a outer cylinder. What is his inside diameter is this one. And right side, there is a inner cylinder. His outside diameter is this mass. Now, this one you like to put inside of this one. And total interference is this mass, delta R. How we can figure out that value? So this figure is not exactly right, this one. Just you remember that difference of radius between inner and outer cylinder is delta R. That means in radial direction along the radius. So you see, this is the, look in the bottom figure. This is, say, if I draw a center line from here to here, then what will be the outer radius of the outer cylinder, this mass, right? And his inner cylinder, inner radius will be this mass. And outer radius of inner cylinder is this mass. And his inner radius will be this mass. But our concern is not this one, is not this one. Concern with this one. So you see right over here, this one you like to put inside of bigger one. How you can put it? One thing, you can cool down this one in liquid nitrogen, then it will shrink. Then you put inside of this one. After inside of putting this one, he'll try to be expand, right? He will push him along the direction. And this one, outer one, he'll push him right over here along downward direction. He'll push him along this direction. Okay. So right now we see total interference is how much? So total interference is coming, this mass, arrow should go opposite direction. On second, total interference will be this mass and this mass, right? This was the difference. So after assembly, both have a common radius is showing with red line. So initial interference was this mass, delta R. And after you pressurize or after assembly, this coming the common radius. So from the common radius, the inner cylinder, he has to reduce his diameter. And outer cylinder, he has to shrink that much. And he has to also shrink that much, but outer cylinder is not shrink. That means he has to increase the radius, right? And value of increasing will be this much, and he has to reduce the radius this much. So this much I can say this is delta Ri and this is delta R naught. So how do we find now? We found delta R equal to delta Ri plus delta R naught. Now, if both contact pressure, if you know, then delta Ri and delta R naught, we can figure out by using this formula. For example, delta Ri. If you know the contact pressure, then you need to put P into radius. And remember, for the inner radius, inner cylinder, he will feel pressure right over here from outside, right? So you need his radius divided by his value of E into Ti. That means wall thickness, this whole square. R is the common radius. Similarly, delta R naught, this will be P into R square divided by E naught into T naught. Then you can say delta, if this value is given, this equal to delta R naught plus delta Ri. From this equation, easily you can calculate the value of P. Okay, if we found this one. You see, showing right over here. This is outer cylinder and this is inner cylinder. So if we put them inside, then the inner cylinder will feel pressure from outside. Like I'm holding my hand. So this will be inner cylinder. He will feel pressure from outside. Similarly, the outer one, he will feel pressure from the inside. Then I'm holding my hand, pressure will be around my hand, right? So this contact pressure we can figure out if we know the amount of interference, radial interference. If say, for example, interference delta R, radial interference is given say 0.005 millimeter. So you can say 0.005 equal to delta R for inner cylinder plus delta R for outer cylinder. Then you figure out the contact pressure. You have contact pressure, then you figure out the stress in this cylinder, in this cylinder. Remember, we don't put the any fluid inside. We're just trying to figure out if there is interference of if we like to make composite pressure vessel, then what will be the pressure at the contact surface? And also, I'm not sure who will teach you the machine design in the next semester. In the machine design, we teach thick wall pressure vessel, and we see if there is a interference, it is beneficial. Number one thing, easy to manufacture, cost is low compared to you make with one plate. Other thing, due to the contact pressure, you can pressurize more. If you make with one plate, then you cannot pressurize that much. Another benefit, say after 5 years, you inspect that there is any crack developed or no. You look around, if you see the outer one right over here, little bit cracked, or it get corroded, just change the outer one. But similarly, if you found that right over here some crack, right over here some corrosion, then you change it the inner cylinder. It's easy. But you make with one huge thickness plate, it is expensive, then say if the crack developed right over here, then what will happen? It will change the whole cylinder. So that will be is expensive. That means you need to build a new one. Okay. Now I give you a real life example of it. I used to that company is Boeing. they service on the military aircraft. So outside you see the aircraft skin like that. They joined with the rivet over here, rivet over here. Okay. Now say certain airplane, they need maintenance or they need certification. For car, every year we need fitness certificate for your bike. In our country, we take the car in BFTA, even they don't drive. They just look the paper, okay, you are done. Just open the hood, make sure the your serial number on the paper and in the engine block is same. That's all, right? But in other country, they'll take your car, say call the light, they will drive around 10 minutes. They make sure your brake working, signal light working, nothing wrong with the engine. Then they will give you for 1 year certification. Similarly, airplane or even in a military airplane, still they need certification after certain year. Say you are giving a certification on airplane, you look around and you see there is a corrosion or crack developed in the panel. You'll say, hey guy, you cannot fly this aircraft. Your aircraft is ground. You have that authority unless you fix it, this portion. So how you can fix it? You need to change this panel. They call it panel, part of the skin. So this rivet, you need to take it out. So all the rivet is very soft material. They have a machine, they take it out and say you are putting a new plate and try to join there. Say initial rivet size, just for example, is 0.575 inch diameter. The whole diameter is this much. Now, so your whole diameter hole in the skin is this much that I put it over here. So if you put a rivet of same diameter, say rivet diameter is also 0.575. Then if you put, what will be happen? It will fit, but it will transition fit. That means rivet there will be rubbing around this wall of the hole and this rivet surface. It might develop cracked. The skin panel will be vibrate. So you need to stop it. So how we can do it? So you cannot make this hole smaller, obviously not. So how to do this rivet? You need to make little bit oversize. So 0.75, you make it rivet 0.78 inch. So now how this rivet with this diameter you like to put in this hole? It will not go easily. You cannot hammer it. That will not permit. Even aircraft industry, they will not allow you to heat up this panel. So only option you have, you cool down the rivet with this size. They put minus 40 degrees Celsius liquid nitrogen. They put the rivet for certain time. Might be 12 hours or 24 hours. Depends on rivet materials, rivet size, and size of the hole. So you put for a long time, then rivet will shrink. You take it with a fork, put in the hole. Then what will happen? Gradually, temperature will come down to room temperature, and it will go back to try to go back this original size, and it will then hold the panel tightly. So just give you an example that how in professional life, this pressure vessel. This is also coming kind of pressure vessel, right? Because if you have a hole, you put oversized rivet, then what will happen? The rivet will try to, after cool down, you're putting right like that. Then coming room temperature, he tried to expand. He will try to occupy his place. And the hole, what will say? He'll say, hey guy, don't push me. So he'll try to apply force along the direction. Okay. So how long our class? Until 2:40, right?
Yes,
Yes,
sir.
sir.
240.
2:40. Okay. I am giving you 5-minute break. Come back at 2:10. Then we'll solve some problem. Okay.
Okay, sir.
Okay. So I stop the recording. So far, what we learn? We figure out the formula sigma T for and sigma L for cylindrical pressure vessel. Sigma T and sigma T we just figure out before. Sigma T equal to PR divided by T and sigma L equal to PR divided by 2T. This formula is applicable only for number one thing, thin wall pressure vessel, and shape has to be cylindrical. In other shape, you cannot apply this formula. But pressure vessel normally depend on geometry. We found two types, cylindrical and other one is spherical. And you will see the spherical pressure vessel has some benefit, but only problem, spherical mean kind of shape like football. Only problem that your contact point have only one point, single point, right? It's very difficult to support, difficult to carry. I don't see that much, but in some special company might or chemical industry, they might use the spherical pressure vessel. Now, you need to know that how stress developed in the spherical pressure vessel. So in before that, I like to told you one thing, that how you calculate the pressure force on a surface. So P equal to pressure equal to force by area. So easily you can say that force equal to pressure into area. 1 second, please. Easily can figure out. Now, say in our head, how look like, or forget about the head, a helmet. You wear helmet, round shape, right? How will figure out the atmospheric pressure force working on the helmet? You have to take the projection area. If you look from the top, your projection area of your helmet might be like that. So you take this area into atmospheric pressure. That will be your force on the helmet. Say you like to figure out pressure on a roof of a building, atmospheric pressure. How will you figure out? You figure out the area into 14.7, you get the force on the building. Now, you will see some fancy building, their roof is not horizontal. I might don't clearly say, for example, their roof a little bit inclined. Okay. Say for example, this kind of shape. So the height of this corner is not the same. That means your this is inclined. The force working atmospheric pressure at the top. I'll figure out that force. Which area you will take. Pressure, you know. If we calculate the area, multiply the pressure, you will get the force. So my question, which area you will take? You have to take the area, like you quiz from the top, then area will be a rectangular. That quiz called project area. You have to take this area. Okay. Similarly, a ball. What will be projected area if you look from the top? Will be a circle, right? A ball, you quiz from the top and bottom, it will be a flat round surface. That will be projected area. A ball, you quiz from the left hand side, it will be a flat. So it will be, you look in our home, our mother, sister, or wife, they cook bread, tortilla, roti, right? You have they take the flour, water, mix, dough, they make it round shape. They press it, right? Then they apply pressure with the roller, it becomes flat. So how we can figure out the force on a curved surface? You just take the projected area. For I see the head of the pen, and this surface is not, completely flat. So how will be the pressure over here? You just take the projected area. That means this will be a completely round surface pi r square. You multiply by the pressure, you will get the force. Okay. Just remember, we have to take the projected area if area is not the flat. So a cylindrical, spherical pressure vessel kind of egg, right? So in the egg surface, if I able to draw kind of like that, say you take out the yellow part, this is the white part, half egg, right? So pressure working inside. So some pressure working, say out this side, downward. So this pressure force will be balanced. Pressure working along this direction is balanced. But pressure working along this direction, who's gonna balance it? It will be balanced by sigma t working all the surface right over here. Sigma t, this sigma t, every point sigma t working. So force working toward right side, how we can figure out? Area into pressure, right? Or area into stress. So right side, stress working sigma t. Now you have to multiply by the area. Now which area will take? You have to take this area, this thickness and round. So what will be the length of this thickness? 2 pi r. Then multiply by the thickness. So 2 pi star r star t. This is the force working right direction. And this much force working in the left direction. So I'm just saying minus. So again, how will the force? Pressure into area. Pressure inside P star, what will the area? Pi into R square. This pi into What happened? Something wrong with my keyboard. Okay, power 2, okay, R square. This will be force working toward left side. This equal to 0. That we put it over here. You will see sigma t. What will the area this stripe? That means if I took this line, that means this area, I like to the thickness area. So peripheral length 2 pi r, and this thickness from here to here is t. You get the area. So 2 pi r into t, and along this direction, this pi r square. So sigma t equal to 2 pr divided by t. This is sigma t, and this is working for spherical pressure vessel. And for cylindrical pressure vessel, what is the sigma t? Pr into t. So which cylinder will carry more pressure? A cylindrical pressure vessel or spherical one? Who can tell me?
Sir, cylindrical.
Cylindrical? No.
Sir,
Spherical will carry more pressure. You see, in the spherical, say you have two pressure vessel. Inside volume is same, made of same material, same wall thickness. Then you figure out the pressure stress in the spherical one. You get sigma t PR divided by 2t. But in cylindrical one, PR by t. So sigma t right over here is higher, double of that one. Did you see? So for the same material, if a spherical pressure vessel is carrying pressure, say 2000 psi in spherical one, then cylindrical will be half. He able to carry only 1000 psi because it develop half to PR by T. So this is the benefit if you use a spherical pressure vessel. But what is the problem? Transport and supporting, and also other problem. Manufacturing is also tough. If you like to make with single sheet, right? You have to go through the casting because shape is spherical. Even you play football, used to you think about 15 years ago, the leather one, leather football is not the single piece. Just make a hexagonal and tie together, right? Because you cannot give perfect spherical shape with a single piece of material unless you do the casting. And some football you might see coming from the China is a single piece rubber, but they make by molding, injection molding by different process. But the metal is very hard to make with injection molding, but nowadays near future might be make with what is called 3D printing. Okay. So if I put a question that what is the difference between spherical and cylindrical pressure vessel, and what is the advantage of it, then we can discuss that for 2-3 mark. Okay. All the formula I summarize over here. Remember, all formula we derive for thin wall pressure vessel. For thin wall, if satisfied this condition, then you can say this is thin wall. Other thing you remember, this is thin wall pressure vessel. If we use this formula, right, this one, then R we use RI. That means right over here. If you use RT right over here, you get higher stress. But some book they use right over here at the middle. So middle mean Ri plus half thickness, then divided by T. But it don't matter if it is thin wall, because respect to diameter, if you took right over here and over here, you'll get little bit difference, not that much. Okay, so that's why I just put it over here. You take at the middle or right over here, both is right. Now we'll solve problem. Number one problem. You see, it's a steam boiler. It don't say it is pressure vessel. This is the diameter. That means what data is given from here, you are getting R, right? R you are getting. Subject to a internal pressure of 1.6 megapascal. It's saying clearly internal pressure. So this data, that means giving you value of P. Boiler is made of 20 millimeter thick plate. So obviously this data is related to wall thickness. And you convert it from a millimeter to meter, make sure all have same unit. Megapascal, you need to convert Pascal, multiply by 10 to the power 6. What is saying? Calculate circumferential or tangential, or you can say hoop stress. That means you need to figure out value of sigma t and longitudinal stress. That means you need to figure out value of sigma L. What is the sigma L? PR divided by 2T. And sigma T, PR in divided by T. Very easy. Okay? Clear? You just put in the formula, you get the result. But did I make any mistake over here? Who can tell me? Anyone? Or should I ask one by one? Tuhin, roll 123. What mistake I made it over here? Tuhin, you are front of your computer? Okay, you fail in this course. I think that you turn on your computer, you went to Coxbazar. So for this course, you'll not be passed, right? Nobody responding.
Yes, sir.
Right? That's good, right? Okay. Then Zakaria Kobir, roll one on people 111.
Yes, sir.
Okay, tell me what mistake I made.
Sir, it's 20 millimeter. We should take it to meter, I think.
Okay, I write down two formula for which pressure vessel.
Sir,
Thin wall pressure vessel, right?
yes, sir,
But
thin wall.
thin wall. But what is a proof that this is thin wall pressure vessel? So that is the mistake I made. Okay, okay. Thank you. Your ID 111. Okay.
Yes, sir.
Prova 153. You are here. Prova 153. You are not here. Seems like. So you get 0 mark for this class, right? Let's see who have on the other end. Shimanto Sarkar for roll 148. You here? Shimanto, you're not here. No attendance. Roll 150. 150. Hasnat. You're not here. Okay. Roll 150 and roll 111 is here. Okay. On roll 121, Asif, you're here? You're not here. Asif. 129, Ishat, Rafi. Rafi, you here? You're not here.
Yes, sir.
Are you here?
Yes,
Okay.
sir.
What is the formula to prove a pressure vessel is thin wall or thick wall? Do you know?
Uh,
Ri greater than 10T, right?
yes, sir. Yes, sir.
That is proof. Yeah. Okay, Tuhin, he's saying he don't have the mic with in the computer. So I agree him still is better, but because why? He didn't say that I didn't have the ear, so I am not listening anything, right? Okay, Tuhin, his ID 129. Okay. So what mistake we made, we have to mention, first you write what data is given, then you have to prove this one, that Ri is greater than 10T. If we satisfy this condition, then we'll say this is a thin wall pressure vessel. So I can use this formula. Okay. Now we'll solve the problem 2. Its diameter is given, it's a spherical, is to be stored gas. Shell plating is 10 millimeters. Shell mean 10 millimeter thick. That means wall thickness is given. So this 20 millimeter data is giving this one radius or diameter. You can figure out. 10 millimeter is the thickness T. It's a material working stress 125 megapascal. What will be the maximum pressure in the tank? Say you graduate from AST joining in the Titas gas field. They're telling you, hey guy, we need to design a pressure vessel. This will be diameter. We have this plate, this material we'll use. You figure out how much pressure we can put in that pressure vessel without explosion, right? So that related to this problem. So 125 is a material working stress. That means this is given yield stress. So you have to design the pressure vessel, make sure that pressure should not be stress. Sigma T is the most critical one, right? Is not more than 125 megapascal. Then you figure out the pressure. So let's see how we can solve it. Did you see the MathCAD file? Hello? You can see?
Yes, sir.
Yes, sir.
Okay, okay, good.
Yes, sir.
Right over here the question. 20 millimeter spherical tank diameter. So it's given internal diameter of the spherical tank 20 meter is given already. So you then figure out the internal radius Ri, di by 2, 10 meter. Thickness is given 10 millimeter. Wall thickness 10 millimeter, convert in meter. Yield strength, working stress mean material yield strength. 125 megapascal, convert in pascal. That means they are saying the pressure stress in the cylinder, if higher than the yield strength, then what will happen? Pressure vessel will fail. So you need to keep stress less than or equal to this mass. Okay. It's a find out maximum permissible gas pressure in the tank. That means P equal to what? So at first, you need to figure out that this is satisfy this condition, Ri greater than 10T. So here is my Ri 10T equal to 0.1. So obviously you see Ri greater than 10T. So we say this tank is satisfying the condition of thin wall pressure vessel since Ri greater than 10T. Now for spherical pressure vessel, this is the formula. P Ri divided by 2T. So we need to figure out this P. We don't know the sigma T. The sigma T value is maximum will be yield strength of the material. So that's why we say sigma T equal to sigma Y equal to this mass. You put this over here, you put value of Ri, value of T, then figure out the pressure from this formula. Pressure I'm getting 0.25 megapascal. So instead of spherical, same problem, I can give you a cylindrical pressure vessel. But I can say you are working in a gas field, you're transmitting natural gas from Kumulia to Dhaka. This is the size of the pipe. This is the pipe material, wall thickness, how much pressure inside you can carry. So in that case, you have to figure out whether it is a thin wall or thick wall. And you see in the pipe, there is no cap, right? But we need to consider that this is both end is close. Then you figure out the how much pressure you can apply. Same thing, say you are working in a gas company, they carry gas from say Borishal to Bhola under the bottom of the river. So you have diameter of the pipe, you know the material, that your boss telling you, could you calculate what the maximum pressure we can transmit through this pipeline, okay? So let us solve the another problem, problem 3.
Sir,
Yes.
sir, can you tell again how did we use the value of yield strength in sigma T?
Okay. Do you remember in how does the stress strain graph look like? This is the your strain. This is the stress, right, of the material. So if you get like that, then yield strength, upper yield point, lower yield point, then going like that. This point is that means fracture strength. This is the ultimate strength. That maximum stress you can apply that material, but it will not come back in previous position. But if you loaded this mass, this point is called yield point, what will happen? Like you pressurize a pressure vessel, its diameter will increase a little bit, but after you remove all the pressure, it will come back in previous position. That means material is not fail. You got it, this point? So in cylinder, what is the stress? Sigma T equal to PR by T, right? So maximum this sigma T you can get if you make sure that sigma T value is not higher than the yield strength. Okay. Okay, our time is getting over. We just solve this problem. It takes only 2 minutes. Okay. Let's see. It's a laminated pressure vessel. That means made of 2 cylinders, composed of 2 thin coaxial cylinder. Is already saying it is thin wall. In the state prior to assembly, when they put together, before they put together, there is a interference between 2 cylinders. Interference means that the diameter inside and outer diameter is not the same. They put a little bit higher than the other one. The outer cylinder is heated, then placed on inner cylinder, allowed to cool. What happened? So you heat up the outer cylinder, heat diameter increase, then you put the inner one, like I'm holding my hand, then at room temperature, outer one will shrink, cool down, right? Then hold them tightly, but at the midpoint, there will be some pressure, that is saying. Both cylinders are made of same material and their common radius is common diameter is 100 millimeter. Find tangential stress in each cylinder or shell resulting from the shrinking of initial interference of diameter 25 millimeter. They don't put inside. They are saying 25.25 millimeter. It's a very little, right? Even you cannot say feel with your eye, right? So it's a thickness of the inner and outer cylinder is given 0.25, 0.2 millimeter, and value of E is given. So what do you need to figure out? You need to figure out the tangential stress due to the contact pressure with the both cylinder. So how we can figure out? At first, you write down what value is given. So laminated pressure vessel of two thin coaxial cylinder. Mean diameter of the assembly, that means R, D equal to 100 millimeter. I convert in meter. Then you figure out the radius divided by 2. Wall thickness of outer T naught 2 millimeter, convert in meter. Wall thickness of inner one is already given right over here, and it's saying diameter interference is 0.25. So how will be interference in the radius? It divided by 2. This is the it's a interference in diameter, this mass, converting interference in radius divided by 2. This is interference in radius. Then modulus of elasticity E equal to 200 gigapascal. You get convert in Pascal. Okay. So what they say? Figure out the tangential stress in each cylinder. That means sigma T naught. This means outer cylinder. This is the inner cylinder. So what is our formula? This one. RT we know for all the cylinder, but we don't know the contact pressure. That we need to figure out first. So how the contact pressure? Due to contact pressure, radius of one cylinder has to decrease, radius of other cylinder has to increase. But both summation of two will be equal to total interference. So this is the formula. Interference in radius, delta R P R square by ET. So just you put subscription, this is for inner cylinder and this is for outer cylinder. If you add these two, that will be total interference. Delta R equal to delta Ri plus delta R naught. So you put right over here, okay? And this E value, EI and E naught has to be same. It's say both made of same material and value of E already given. And both have the common radius. That means this Ri R naught, you can put only R. I put only R. And R is the value of common radius is given right over here. Common radius is 100 millimeter. Over here, 0.05 meter. So you put the formula over here. Value of E is given, delta R, given in diameter divided by 2, we got the delta R. So from this equation, just rearrange the equation, you figure out value of the P. Then you got value of the P is this much megapascal. Now you figure out tangential stress in the outer cylinder, PR by T naught, inner cylinder PR by TI. So this is the result. Very simple. Only at first you need to figure out the contact pressure. So any question in this problem? Anyone has any question?
Sir,
Yes.
so when we heat up the outer cylinder and place the inner cylinder into it, the inner cylinder expands and the outer cylinder shrinks, right?
Now you have two options. That diameter of the inner cylinder, little bit keeping you high. Outer diameter, say this is your inner cylinder. It has a thickness, right? This
Yes.
is outer diameter. Say, for example, his diameter is 29 inch, just for example. And this one you like to put in the outer cylinder. This is outer cylinder. So his inner radius, if it's same 29, then you can put it, right?
Yes, sir.
So instead of say, I'm saying this one has 28.79, just for example, inch. You can put it.
No, sir.
What option you have? How many
Heat the
options?
outer cylinder, and when it will increase diameter, then I will
Then
put
you can put it. Okay. Then he wait, cool, let them cool down. After cool down, he came back to room temperature. Then he tried to go back. Say after heating, this diameter become 29.01. Then easily it will enter the inner one, right? Then
Yes, sir.
when cool down, then what will happen? This radius, it try to come back to previous position, 28.79. Then he has to quiz this one very high, right? He
Yes.
has to quiz because this one has to be 29. So, but they will compromise. Both radius is coming my 28.8. Okay, 28.89. That means this one going little bit bigger and this one going little bit low. That means shrinking.
Sir, is there any effect on inner cylinder, the outer cylinder heat?
No, you will heat separately. You don't need to heat up both together. Other option you have, you cool down this one instead of heating this one. If you cool down this one, then put inside, then after come back to room temperature, then this will increase, diameter will increase and you hold it tightly over here. Okay?
Okay, sir.
So both way you can do, but normally a lot of, depending on what you're making, especially some aircraft industry or submarine, or you making pressure vessel, space shuttle, right? Is kind of pressure vessel. Inside is pressurized. So in those case, they will not allow to heat up. They might say better to cool down. Like I give you example, you putting a rebate in the oversized rebate in the aircraft, they'll not allow you to anything to heat in the aircraft structure. So they cool down the rebate, then it shrink, then you put in the rebate hole. Okay.
Okay, sir.
What is your ID?
131.
131. Okay. Thank you for asking question. I always encourage that you ask question. It don't matter. It is wrong or right. You ask question, your confusion will be removed, and from that question, other 5 or at least 2-3 students will learn something. Okay. So thank you very much. We can leave it over here. Hopefully in the next class, we will start new chapter, spring. Okay.
Yes, sir.
And stay careful.